Another example, if we are doing electrolysis of aqueous dilute sodium chloride. So if we have aqueous dilute sodium chloride, so it contains sodium chloride or NaCl, which is having sodium ion, chloride ion, and it contains water as well. It means it contains hydrogen ion and hydroxide ion. If we say it's a dilute, so it means it contains more water and it contains less salt. So there is less chloride ion in this and it contains more hydroxide ion. So this is electrolytic cell, which is having two electrodes, anode and cathode. And the electrolyte contain the ions. The ions which are present, it contains sodium ion, chloride ion, hydrogen ion, and hydroxide ion. For positive ion, what we will do, we will check reactivity. The less reactive will move towards cathode. So we have to check the reactivity, and for the reactivity, to check the reactivity, we have to use a reactivity series. So the reactivity series we have potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, and platinum. Gold is there, gold and platinum, but this is a reactivity series according to the elements which we are using for electrolysis. So we have to check as we go down, the reaction rate of reaction or speed or reactivity decreases. So what are the ions present? We have sodium ion and we have hydrogen ion. So in this question, we have sodium ion and hydrogen ion. So which is less reactive? Which one is less reactive here? Sodium or hydrogen?
Hydrogen.
So hydrogen ion is less reactive. So as a hydrogen ion is less reactive, it is attracted towards cathode. So when we write equation for cathode, when hydrogen ions are there, they will take electron and change into hydrogen atom. But hydrogen is a non-metal, so when two hydrogen ions are there, they will take two electrons and it will change into hydrogen gas or hydrogen molecule. Whenever a gas is given off, so we will see bubbles at cathode. But for anode, for reaction at anode, we check for positive, for negative ion, we check the amount. The ion which is more in the solution will move towards anode. So ion which is more in the solution will move towards anode. So which ion is more, which negative ion is more in this electrolyte? Chloride ion or hydroxide ion?
Hydroxide.
Hydroxide ion.
Hydroxide ion. And for hydroxide ion, the equation you have to learn or memorize. If hydrogen, you have to learn this equation. Whenever hydroxide ions are there, so basically when 4 hydroxide ion will move there, they will give oxygen, they will give 2 water molecules. So when 4 hydroxide ions are there, 1 hydroxide ion will lose 1 electron, 4 hydroxide ion will lose 4 electrons, and it will give oxygen, and it will give 2 water molecules. This is a equation which you have to learn or memorize for hydroxide ion specifically. When 4 hydroxide ions are there, they will lose 4 electrons, and after losing 4 electrons, they form oxygen gas and give 2 water molecules. Whenever a gas is given off, because oxygen is a gas, so whenever a gas is given off, what is the observation? The observation is bubbles. So as a hydroxide ion will move, you will also observe bubbles due to oxygen gas. And what happened to electrolyte? So what happened to electrolyte as you remove chloride, you remove hydrogen ion and hydroxide ion, both are removed. So you are left with what? You are left with sodium chloride. And because you remove H and OH, so hydrogen is removed and hydroxide is removed. So basically water is removed. So if you remove water from the substance, what it will become? It will become concentrated. Because if amount of water increase, the substance become dilute. If amount of water decrease, the substance become concentrated. But in short, you can write what happened to electrolyte. So electrolyte, you're left with NaCl. Is it clear? So for hydroxide, you have to learn or memorize this equation for formation of water and oxygen gas. This part. This you have to learn. Whenever hydroxide ion will move there, this is a fixed equation. 4 hydroxide ions will lose 4 electrons, give oxygen and water molecule. Whenever oxygen gas is given off, so you will observe bubbles. And when hydrogen is released or produced, you will also observe bubbles.
Sir?
Yes?
Sir, when we electrolyze aqueous dilute sodium chloride,
Yes?
the electrolyte becomes concentrated more. So
Yes.
as the sodium chloride is getting more concentrated, and if we keep electrolyzing, eventually do we get chlorine?
Yes, eventually you will get chlorine. Because what happened initially in the beginning, it was dilute sodium chloride, so hydrogen and hydroxide ion was moving there. But what happened as the amount of salt increases, then hydroxide ion will not move, then chloride will move. Is it clear?
Yes, sir. Thank you.
So for hydroxide ion, whenever hydroxide ion will move there, you have to learn this equation for movement of hydroxide ion. When 4 hydroxide ions are there, they will lose 4 electrons and it will give oxygen and 2 water molecules. This is a fixed equation which you have to learn or memorize for hydroxide ions. Other equation you can form easily, but for hydroxide ion, you have to learn this equation. take the screenshot for this. I'll give another example. Another example, if you are doing electrolysis of potassium dilute, potassium chloride, KCl. Dilute or aqueous dilute, same thing. So if I say it contains potassium chloride and it contains water, H2O. So what are the ions present? The ions present, it contains potassium ion, chloride ion, hydrogen ion, and hydroxide ion. These are the ions present in the solution. So electrolytic cell, so it contains anode and cathode. Anode is made up of carbon or platinum, and cathode is also made up of carbon or platinum. What are the ions present? The ions present, it contains potassium ion, chloride ion, hydrogen ion, and hydroxide ion. Because it is a dilute, so the term dilute means it contains more water and it contains less salt. So more hydroxide ion is there and less Cl ion. But for positive ion, at cathode, the positive ion, the criteria for a positive ion, what we do, we check the reactivity. So for positive ion, check reactivity. The less reactive will move towards cathode. Which is less reactive here? Like we have two positive ions. So which is less reactive? Positive ion. Sodium, potassium or hydro. The two ions which are present here, we have potassium ion and we have hydrogen ion. Which is less reactive?
Hydrogen.
So hydrogen ions are less reactive. So as the hydrogen is less reactive, it will move towards cathode. For hydrogen, hydrogen is plus. It will take electron and change to hydrogen atom. But when two hydrogen ions are there, they will take two electrons and it will form hydrogen gas. So whenever a hydrogen gas is there, when a non-metal is released, so what you will observe? You will observe bubbles. For the negative ion, the criteria is the amount. So the ion which is more in the solution will move towards anode. So which ion is more in this example in the solution electrolyte? Which ion is in greater quantity within the electrolyte? Chloride ion or hydroxide ion?
Hydroxide ions.
So hydroxide ion is more. So and for hydroxide ion, you have to learn this equation. Whenever hydroxide ion will move there, they will lose 4 electron. It will give oxygen and it will give 2 water molecules. Because oxygen is a gas, so here also you will see bubbles. So you will observe bubbles at anode and you will observe bubbles at cathode. Now what happened to electrolyte? So what happened to this electrolyte? Because you removed H ion, you remove OH ion. So what you're left with? You're left with KCl. Because H is removed and OH is removed, so you're left with potassium chloride, which contain less water because hydrogen and hydroxide ion are moved. Is it clear? Any doubt in this?
Sir, I have a question.
Yes.
Sir, what is the water released in which form is it released? Is it released as vapors or
This water,
liquid? Yes.
this water is not
Yeah.
really normally, because what happened when we do electrolysis, if the temperature, it depends on the temperature, but normally it's not in a vapor form. It will be there within the liquid, in a liquid state. This water which is formed is not water vapors. This is a water in a liquid state. If the temperature increase, then it can form vapor. But the temperature of aqueous electrolyte is not above the boiling point of water. That's why for a molten substances, it produces vapors normally due to the temperature because we have to supply energy. But for aqueous, we don't heat the electrolyte. That's why the water which is produced here is in a liquid state rather than in a vapor form. Is it clear?
Yes, sir.
Any doubt in this electrolysis of dilute solution and concentrated? One more thing, I give you the exception that if there is a sulfate ion, if there is a sulfate ion, nitrate ion, or carbonate ion, even though they are more in the solution, they will never move. I'll give that example now. Example, you have concentrated aqueous copper sulfate. So you have a solution which is concentrated aqueous copper sulfate. So it contains copper sulfate and it is aqueous, so means it contains water. The ions which are present, it contain a copper ion, it contains sulfate ion, and it contains water. So water means it contains hydrogen ion and hydroxide ion. Because we mentioned it is a concentrated, so concentrated means it contains less water and more salt. So less OH ion will be there, more sulfate ions. If you make this electrolytic cell using the electrodes, left hand side is positive example, right hand side is negative. The one which is connected with a positive terminal is called anode, the other one is cathode. And for unreactive, the anode should be either made up of carbon or graphite, you can say, or platinum. And cathode also consists of either carbon or graphite or platinum. And the ions which are present in the solution, it contains copper ion, it contains sulfate ion, it contains hydrogen ion, and it contains hydroxide ion. For positive ion, the criteria is the reactivity. So for positive ion, we check the reactivity. The less reactive will move towards cathode. So which ion is less reactive? You will check the reactivity here. So what are the ions present? We have hydrogen ion and hydroxide and copper ion. Which ion is less reactive?
Copper.
Hydrogen or copper?
Copper.
Which one is less reactive?
Copper ion.
Copper ions are less reactive. So as the copper ions are less reactive, the copper ions will move towards cathode. So if we write the equation for cathode, copper ions, which is +2, they will take 2 electrons and change to copper atom. So copper ion gain 2 electrons, change to copper atom. So what we'll observe the copper metal. A brown copper is brown or pink is also acceptable. So brown or a pink solid will form, or a shiny solid you can also say. So a shiny solid is formed at cathode. But what will happen at anode? The criteria for anode, what is the criteria for anode? The ion which is more in the solution will move, the negative ion which is more in the solution will move towards anode. But there are exceptions that these ions cannot move because of their size, sulfates, nitrates, even though they are more in the solution, but they will not move, and carbonate. So what will happen, even though we have more sulfate, but exceptions are sulfate, nitrate, and carbonate will not move even they are more. So which ion will move?
Hydroxide will move.
So hydroxide ion will move, even though hydroxide ions are less, but because the sulfate ions cannot move because of their size, so they will never move. So sulfate ions, if I write sulfate ion, that's wrong, because of their size, even though they are more, they cannot move. So which ion will move? Hydroxide will move. And when hydroxide ion will move, that's a fixed equation. When 4 hydroxide ions are there, they will lose 4 electrons. It will give oxygen and it will give water. And whenever oxygen is there, so you will see bubbles. Then what happened to electrolyte? So what happened to electrolyte? Because you remove copper, you remove hydroxide. So what you're left with? You're left with hydrogen ion and you're left with sulfate ion. So what compound they will form when hydrogen and sulfate ions are there? This 2 will come with hydrogen and 1 will come with sulfate. So the compound which they will form H2SO4. And this H2SO4 is known as sulfuric acid. So the electrolyte will become acidic. As you pass the current through aqueous concentrated sodium copper sulfate, so copper ions are less reactive, will move towards cathode. Hydroxide ions, even though they are less in the solution, but move because sulfate cannot move. So you are left with hydrogen ion and sulfate ion. And hydrogen ion and sulfate ion, what compound they will form? It will form H2SO4. And H2SO4 is also known as sulfuric acid. So this electrolyte will become acidic. Is it clear? Electrolysis of concentrated aqueous copper sulfate. Any doubt in this?
No.
take the screenshot of this. So write equations for cathode, anode, and mention change in electrolyte when using graphite or platinum electrode. So these are some questions I want you to solve. But this is a homework, but send it before, exam before the class, tomorrow's class in the morning. Molten sodium chloride, aqueous concentrated sodium chloride, aqueous dilute sodium chloride, aqueous concentrated copper sulfate, aqueous concentrated HCl, aqueous dilute HCl, molten PbBr2, concentrated H2SO4. So molten NaCl, I will write the formula NaCl here. Sodium chloride and water is there as well. This also contains sodium chloride and water. Concentrated and dilute you have to identify. If it is concentrated, it means it contains more salt and less water. If it is dilute, it contains more water and less salt. Aqueous copper sulfate, so it contains CuSO4 and H2O. It's aqueous concentrated, so less water and more salt. Aqueous HCl, concentrated HCl, so it contains HCl and it contains H2O. Concentrated means more HCl and less water. Dilute HCl means it contain more water, less HCl. Molten PbBr2, so it contain lead ion and bromide ion. And H2SO4 concentrated, aqueous concentrated or concentrated here, it means it contain water. So it is H2SO4 and water is there and it's a concentrated. So it contain more H2SO4 and it contain less water. Take the screenshot of this. I want you to solve these questions related to electrolysis. Better draw the electrolytic cell as well and show the movement of the direction of electrons as well. The direction of electrons is always, electrons in this case will come out from negative terminal. So this will have majority electron and electron removed from anode. So this will have majority positive charges. So this as a homework you will solve and submit it tomorrow before the class. Everyone should send this homework. Some of the students are not sending the homework regularly. So be regular and send the homework. The topic electrolysis is not finished. This is like 60% of the chapter we are done with. Other topic we'll discuss tomorrow. And now I will discuss the homework, the weekly homework with you. Take the screenshot and share on the group. Take the screenshot and share on the group so that if anyone is not able to copy, he can copy later.